Hi everyone. Let's see one of the gate question which was asked earlier. What is the behavior of the following one input flip-flop X, and they have given the circuit and they have given various kind of options. Okay. So guys, if you are able to observe clearly this particular circuit diagram, earlier we have seen similar kind of circuits which we have constructed, right? While explaining the concepts of conversion of flip-flops. So here they are simply given the circuit diagram for implementation of X using T flip-flop. Am I right? So earlier we have seen something like implementation of X1, X2 flip-flop using JK flip-flop, like that, right? Similarly, I can write this as implementation of X flip-flop using T flip-flop, right? Okay, fine. Anyway, at the end, this also will lead to any one of the flip-flop, any one of the given options flip-flop. That is what they are saying. So basically, how can we do this one? So let us try to solve it. So if I am going to have the input X and this is the output Q, right? So I can say that Qn, and you have to define for Qn plus 1. You have to define for the Qn plus 1. But to define the Qn plus 1, Qn plus 1 value is T. Qn plus 1 value is T. So you have to find the value of T first, right? What is the value of T? T means which is X XR with the Qn. This is Qn, right? X XR with Qn. So T value X XR with Qn. So what is the possible values? 0 0 0 1 1 0 1 1. What is XR of 0 0 0 0? XR of 1 1 is 0. And when they are varying, they are going to be 1 1. So we can call XR operation a modulo 2 operation, modulo 2 addition operation. Okay. Now, if I am going to have T value as this one, you got, right? Next, what might be the Q1 plus 1? What might be the Q1 plus 1, right? So try to observe when you are going to have T as input, Qn is the present state. What might be the next state? What you have to know here? You have to understood how the T flip-flop is behaving. Right? This is what the T flip-flop, right? T flip-flop is the input. Q1 is the present state. What might be the Q1 plus 1? How it is behaving? When T is 0, it is going to act as a latch mode. When T is 1, it is going to act as a toggle mode. I hope you remember this point, right? So based on that, if you are able to observe, this is 0. For 0, it is going to act as a latch mode, right? This Q1 is going to be act as 0 1. For this 0, this 1 is going to act as 1. What about 1? When 1 are the inputs for T, it is going to act as a toggle state. So this is 0, this will be the 1. Right? Means we find the next state. But they are asking for is what kind of behavioring, right? Behavioring is going to define by the characteristic table, right? This is what we can call it as characteristic table. Yes. Means here for the inputs of X, for the present state of these values, it is going to produce, this is the state. Then what you can say, when 0 is input, 0 output, 0 is input, 0 output, meaning that irrespective of Qn, it is going to produce 0. It's going to produce 0. Okay. When it is 1, it's going to produce 1 1. So I can say that this is a kind of reset mode. This is a kind of set mode. But what they are asking, they have not given like that. They have given some different manner as a D flip-flop, right? So can I say that this is acting as a kind of a D flip-flop? Yes, this is acting as a D flip-flop because D flip-flop is something like data flip-flop, right? Data flip-flop, or you can say simply delay flip-flop. Basically, after some point of time, definitely is going to produce the same output, right? For X value of 0, next state is 0. For X value of 0, next state is 0. 1 1 1 1. Whatever the input that you are going to give, that input is going to produce at the output section. So you can say that the corresponding behavior of the circuit is acting as a D flip-flop. That's it. This is one of the question they have given, right? Similarly, the same kind of question is asked in another year in the gate. So can you able to solve it? So take your time by pausing the video and you can solve it. Right here again, if I say this value is also x, so simply I can say that implementation of x using t flip-flop, using d flip-flop, not the t, d flip-flop. Right now, try to observe. I have given x value, I have qn, I need to find out qn plus 1. This is my final output characteristics table. Final output characteristics table. See, observe 0, 0, 0, 1, 1, 0, 1, 1. Okay. If I would like to define this d, the d should be first qn xr with x. Qn xr with x, right? So, why I need to find out to get the qn plus 1, I have to get the first d value. So, d value is x xr with qn. X xr with qn. So, we are going to get 0, 0. Here you are going to get 1, 1. You are going to get 1, 1, right? Now, it is a d flip-flop. It is the present state qn. Present state qn. What might be the next state? In d flip-flop, if 0 is given, the same 0 is going to produce out the output section, right? If 1 is given, the same 1 is going to produce out the output section. Yes. So, it doesn't think about the present state. So, this is the corresponding characteristics table. Now, with this, you can able to find what does the meaning of this particular characteristic equation table, right? So, if I am going to have 0, 0, you are going to get 0, 1, which is acting as present state. If I am going to have 1, 1, which is acting as 0, 1 and 1, 0. If you are able to observe the t flip-flop, how the t flip-flop is working? T, qn, qn plus 1. T is 0, latch state. T is 1, toggle state. Right? Here also I have written, right? So I can say that this particular thing will be a kind of t flip-flop. I hope you understood clearly. Thank you.